Hi, welcome to Lesson 20, Session 3. We are going to be working with tiling a rectangle to find area. Today it's going to be a little bit different because in the past we've been working with fractions that mostly, honestly, they mostly have unit fractions, but they also are all not improper fractions. But now we're going to start to dabble a bit into improper fractions. That means that our fraction is actually greater than 1, which means that our area models are going to look slightly different. And so there's a couple of different ways that we can do our tiling with a rectangle to find the area. And I will be kind of exploring both of those with you. So we're going to be working in our Ready Classroom Math workbook. We'll be on pages 413 through pages 418. So go ahead, take out your Ready Classroom Math workbook and turn to page 413. All right, on page 413, it says this. A rectangular postage stamp has a length of 3/2 inches and a width of 3/4 of an inch. What is the area of the stamp in square inches? So, what are we talking about? We're talking about stamps. These are stamps. You put them on a letter to mail them in the mail. And this is a rather large stamp because the stamp is 3.5 inches wide and 3/4. So I guess they're calling this the length. So 3.5 inches long. I mean, three halves of an inch, not 3.5, but 3/2 of an inch wide. Excuse me, long, and 3/4 of an inch tall. Woo, it's getting late. And we are going to, what is it that we're trying to solve? We're trying to solve what is the area of the stamp in square inches, and then what is the important information. The length is 3/2 of an inch, and the width is 3/4 of an inch. So just to get us started, I'm going to warm us up and we're going to do just the equation. We know this method, we've figured it out, we've learned it, and we're really good at it. So let's do that first. So we know that we have 3/2 times 3/4. And that is going to give us an answer. Well, that's 3 times 3 in our numerator and 2 times 4 in our denominator. 3 times 3 is 9. 2 times 4 is 8. So our answer is 9/8 of a square inch. We also know that we can take this improper fraction and turn it into a mixed number. 9/8 is equal to 8/8 plus 1/8, which is equal to 1 and 1/8 of a square inch. So now we know our answer. We know that we're looking to get 9/8 of a square inch or 1 and 1/8 of a square inch. So I'm going to show you how to draw the area model. Now, for this area model, I'm going to tell you that most of the time when you draw your area model, you're going to draw your area model like normal. But the improper fraction needs to go on the top. I promise you it's just easier. So we're going to put the 9/8 up here on the top, and then we're going to put, oh, not the 9/8, excuse me, the 3/2. 3/2. What am I thinking? There we go. We're going to put the 3/2 up on the top and the 3/4 on the side. Now watch how this goes. Now, first, let's deal with this 3/2. So we know that the denominator tells us how many parts we need to break the whole into. We need to break it into 2 parts. Then the numerator tells us how many parts we need to shade in. So we need to shade in 3 parts. Well, we've got 1 part to shade in and another part to shade in, but what do? We don't have another part to shade in. We need to draw another hole. So we're going to draw another hole, and that other hole we're also going to break into 2 parts. Now, the most important part of all of this is we need to remember that this here is our original hole, okay? We need to remember that, and we'll keep that in mind later. Now, Now we can shade in 3 parts because that's 1/2, 2/2, and 3/2. So now we've drawn the 3/2. Now the 3/4, luckily, is a little bit easier to deal with. So we know that this 4 is going to tell us that we're breaking this into fourths. So you can go ahead and draw your fourths all the way across. And then we're going to shade in 3 of the rows because it's 3/4. So we're going to shade in, and I'm just shading them in all together. I'm cheating a little bit, but that's okay. And then our overlap is going to be our answer, or our numerator, excuse me. The overlap is the numerator. So let's count the overlap. Remember, this is the overlap. Is 1, 2, 3, 4, 5, 6, 7, 8, 9 parts is the overlap. That's the part that's shaded in by both the rows and the columns. Now, the denominator is the total number of equal parts in a whole. Now, this is the hardest part of when you are dealing with an improper fraction or a number greater than one, a fraction greater than 1. When we do the denominator, in the past, we've counted all of the squares to find out what the denominator is. When we have to draw this extra whole over here, when we get to the denominator, we kind of have to forget that it's there. We only want to know how many equal parts are in the whole. So remember when I went back and I shaded my purple highlighter around this hole here? We want to know how many equal parts are just in this section here. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 parts in one whole. I'm even going to change. I said in a whole, but I'm going to say in one whole. Okay, so make sure when you're figuring out your denominator that you count how many are in one whole. This is the only time when you're not going to count all of them, when you have one of your factors that is greater than 1 or is an improper fraction. All right, let's go ahead and go to the next page. We're going to talk a little bit more about this, but I think you guys have a pretty good understanding. I drew my area model this way. On the next page, I am going to warn you that they drew their area model a little bit differently, but I bet that you'll understand it once we get there. All right, so you can picture tiling the rectangulars. So this is the same problem as before. A rectangular postage stamp has a length of 3/2 of an inch and a width of 3/4 of an inch. What is the area of the stamp in square inches? You can picture tiling the rectangular stamp with smaller rectangles that have unit fractions as side lengths. So you can tile a unit square with rectangles that have unit fractions as side lengths. Each rectangular tile is 1/2 of an inch by 1/4 of an inch. So we know that one of these squares is going to be 1/2 of an inch times 1/4 of an inch. And we're going to talk about how we got that in a moment. You can also use 1/2 of an inch by 1/4 of an inch tiles to tile a rectangular stamp with the length of 3/2 of an inch and a width of 3/4 of an inch. So if we add 1/2 plus 1/2 plus 1/2, it's going to equal that 3/2 that we see here. So what we've learned is that the length of just one of these sections is 1/2 of an inch because we have 1/2 of an inch plus 1/2 plus 1/2 equals 3/2. Now, and those are our columns, okay? Now in our rows are 1/4 of an inch plus 1/4 of an inch plus 1/4 of an inch, which equals 3/4 of an inch. This method, I would say, is a little more difficult, but you're still going to get to the same result. So when you look here, you can see that we have labeled, so now we have, how many parts do we have all together? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 tiles that are shaded in. So we know that there are 9 tiles. Now, what is the area of just one of these tiles? How would we find the area of one tile? We would multiply 1/4 times 1/2. When we multiply 1/4 times 1/2, we get 1/8. So one tile has an area of 1/8. So if we have 9 tiles and one of these tiles has an area of 1/8, if we multiply 9 tiles times the area of one of the tiles, which is 1/8, we're going to get 9/8. So this is just a different way to look at it, but this is called, I would say this is more called tiling, and then this example down here is what I drew on the last page, which would be more of the area model. So I would say we call this tiling, we call this an area model, and then down here, an equation. So that's 3 different strategies. I will say that most of you will probably stick with this model here. It's a little bit easier to draw, but I wanted to show you what that looks like. Now we're going to go on and talk a little bit more about these models on the next page. So number 1 says, use the unit square in picture 1 to explain how to find the area of one tile. So we're looking here and we're explaining how to find the area of one tile. But the good news is I already did it for you. So the unit square shows the tile is 1/2 of an inch times 1/4 of an inch. So we know the product is 1/8 of an inch. And we did that math here, but I just flipped it, but it's okay. 1/4 of an inch times 1/2 of an inch, or in this case, 1/2 of an inch times 1/4 of an inch equals 1/8 of an inch. Then, once we know what the area is of one unit square, then this is just proving how we found that. If we look at this section here, explain why we can use this picture to show the equation of what is 3/2 times 3/4. So we can use this equation, this picture, because we are showing 3/2 times 3/4. We used unit fractions to draw our tiles. And that gave us, we broke apart 3/2 into 1/2 plus 1/2 plus 1/2. Each of these is a unit fraction because the numerator is 1. And then we broke apart 3/4 into unit fractions by 1/4 plus 1/4 plus 1/4 because we have 3/4. So that's how you can draw your unit fractions. Now, if we write an equation that uses the area of one tile to find the area of the stamp, we know that we have 9 tiles times the area of one tile, which equals 9/8. So we know that the area of the entire section is 9/8 of a square, or 9/8 square inches. Now, if we look at the formula down below, if we look down here and model it, we're going to complete the equation to find the area of the stamp as shown in the model. So here, if we multiply our numerators, that's going to be 3 times 3. If we multiply our denominators, that's going to be 2 times 4. So 3 times 3 is 9. 2 times 4 is 8. The area is 9/8 of a square, 9/8 square inches. Now, does using the area formula equation result in the same area you found by tiling the rectangle? So, in these two methods, did we get to the same results? The answer is yes. Both the equation and the area model show the same product. 3/2 times 3/4 equals 9/8, or 1/8 times 9 equals 9/8. Either way you do it, you get to the same result. So now, looking back, we want to figure out which strategy is the strategy that we probably prefer the most. So we have 3 strategies that we've learned. We've learned tiling, we've learned area models, and we've learned equations. So which strategy is your best strategy? Tiling, area models, or equations? Go ahead and fill in your best strategy and tell me why you like it the best. Pause the video. When you're done, you can go to page 416 for us to do a little practice. Okay, so number 7 says this: Bernice's rectangular math workbook is 2/3 of a foot wide and 5/6 of a foot long. What is the area of a page in her workbook? Show your work. So because I love using the equation model, and I know we're going to do an area model or tiling down here, we're going to go ahead and we're going to use an equation. So we know that we have 2/3 of a foot times 5/6 of a foot, because those are the two values we've been given. And so when we multiply our denominators, 2 times 5 equals 10, 3 times 6 equals 18. So our answer is 10/18 of a square foot. Because remember, we're multiplying to find the area. When we find area, we have to remember to put square before our unit. Now, number 2 is going to take us a little bit more time because it's not quite as easy as just doing the equation, because we're going to show how to do this. So what we're going to do is we're going to show one way to use tiles to find the area of the rectangle below. What are the length and the width of your tiles? What is the area of the rectangle? So I'm not worried about what are the length and the width of our tiles. We'll talk about that, but we're going to go ahead and use tiling as our method. So when we use tiling as our method, we need to create our columns all need to be unit fractions. So our columns need to be in fifths, and we need to have, and so we're going to make it into fifths, but in this case, we're going to look at the 7 to tell us how many fifths we need. So we need 7/5. So we're going to break this, our columns into 7 sections. So there's one section, and now I'm going to break the rest into 6 by breaking it up. So it doesn't have to be 100% even, but now we have 7 sections. So this is 1/5, 1/5, 1/5, 1/5, 1/5, 1/5, and 1/5. When I add all of these fifths together, it equals 7/5. So I've drawn 7/5. Now, going side to side, I'm going to draw 4/5. So instead of, normally I would turn this into 5 rows. I'm not going to do that. I'm going to draw 4/5. So then I'm going to look and go, okay, well, I need 4 of them. So I'm going to say, here we go. So this is 1/5, 1/5, 1/5, and 1/5. So now we know how many fifths we have altogether. That's a lot of fifths. So we need to figure out how many sections we have. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. We have 28 tiles. And then what is the area of one of these tiles? Well, we know that one side is 1/5 and the other side is 1/5. So the area of one tile is 1/5 times 1/5, which equals 1/25. So to find the area of this whole section, we're going to say, what is 28 times 1/25, which equals 28/25. So the area of a square, what is it? What are we talking about? Square miles. So, and then what is the area of one tile? Is 1/25. The area of the entire section is 28/25. That one's a little rough. I don't know if that method will be the method that you guys use, because we could have also just done this. What is 4/5 times 7/5? 4 times 7 is 28. 5 times 5 is 25. When it's that easy to do the math, it's kind of hard to justify drawing the picture. But I think that drawing the picture helps you to understand what it really looks like. Now for number 9, because we just went through all of that and I'm sure your brain is completely fried, we're going to go ahead and just use the equation to solve this problem down below. John's rectangular poster is 7/4 of a yard in length and 2/3 of a yard in width. What is the area of John's poster? Well, 7 times 2 is our numerator. 4 times 3 is our denominator. 7 times 2 is 14. 4 times 3 is 12. Our denominator, and then we know that it is square because we're talking about area. Area, square, yards. And we come over here and we find that B is our answer. With that, you're going to go ahead and do pages 417 and 418 on your own. As always, if you have any questions, ask your teacher.